Am I audible?
Yes, ma'am.
The screen is visible.
No, ma'am.
No, ma'am.
Ma'am.
Any doubts so far? The asymptotic notations.
Ma'am, the omega notation.
So we were discussing about asymptotic notations. Asymptotic notations are the representation or mathematical way of representing the time complexity and space complexity of your algorithms. In asymptotic notation, we have three methods of representing the time and space complexity. The first one is big O notation. Second one is called big omega notation. We are using the symbol, and big theta notation, theta symbol. So in big O notation, what we are doing, we are taking the upper bound, and say you are writing an exam. Some students are completing the exam within 1.5 hours, 2 hours. Even though maybe some students are really writing all the answers, and they can able to complete the exam within 2 hours itself. But the duration for the given exam is 3 hours. So if they can able to complete the exam within 2 hours, we can say is the best case. Maybe they got all, they know the all the answers, and whatever they studied it came, and they can able to complete the exam within more than what within the 2 hours. So they are less than what is that 3 hours they are completing the exam. So that is called best case, and the minimum time they are taking to complete the exam, lower bound, and they are completing within. So they got all the questions well known to them. So that is called best case. But some students need more than 3 hours also to complete the exam. So it means they need another 10 minutes or 20 minutes. So it means they are taking the maximum time per board. The given time is only 3 hours, but they need another 10 minutes or 20 minutes. So they're taking the maximum time. Maybe they're writing in detail, or they are recollecting the answers and they are writing. So it is called worst case. And they are completing the exam within the exact time of 2 hours 55 minutes, and they are revising the content also, not taking more than the minimum time or maximum time. So that is called exact bound, that is called tight bound, or average case. That is represented using theta notation. Any doubt what is big O notation, big omega notation, big theta notation? Say for example, to analyze how much time we are taking for the algorithm of insertion sort. So you may be knowing what is insertion sort. So for the given n numbers, we will find out the smallest number from the given list, and that number will be placed in the first position. So that is called finding the smallest in the array of 10 numbers, placing it in the first position. That is called insertion sort, and finding the next smallest number from the n minus 1 numbers, placing the second smallest in the second place. From the n minus 3 numbers, finding the third smallest number, placing it in the third place. So the like that we are repeating the process. In the best case, when the array is already in sorted form and the algorithm performs only n comparisons, that is the first number is compared with all other numbers like that. No swapping also required to swap the numbers. If the first one is bigger, second one is small, then that is called best case. You are told to do some job, you are going to the particular place to complete the task, but the task is already completed, so you don't have any work to do, then it is called best case. And if it is average case, then when the array is in random order or in the reverse order, the algorithm performs n square n factorial 2 n square comparisons and swaps. So when the order is the given number is in the reverse order, instead of we have to sort the numbers in ascending order, but the number is in the descending order. In that case, we need to compare the first number. All the numbers will be compared with all other numbers, and the maximum number of swaps must be done to get the sorted list. So that is called average and worst case. For the same algorithm insertion sort, the best case will be order of n and order of n, but in case of average and worst case, it will be big O of n square. So so we are taking minimum bound, then it is called best case. So you are taking the maximum time, then it is called worst case. The same way, the space complexity, uh, for each number to store, we need order of one, order of one accelerated space, as it requires constant amount of extra space to store the numbers as well as to swap the numbers. So we need a temporary variable to swap the elements also. And in asymptotic notation form, best case we are representing using theta notation. So order of n, order of n, order of n for the insertion sort, and the average sort will be theta of n square, theta of n to the power of 2, theta of n square, the average case. In the worst case, big O of n square, big O of n to the power of 2 and n square. So any doubt? So we discussed what is asymptotic notation, what is big O notation. Here we are taking the upper bound, and we are taking the upper bound, and because we are taking the maximum, then it is called worst case scenario. So where we need, for n numbers we need order of n square, so that is called big O notation. But in case of big omega notation, what we are doing, so it takes the minimum time required for processing the or sorting the elements, so the lower bound. So it is the best case scenario. In best case scenario, for n numbers we need only n, but in case of big O notation, it is worst case where we need order of n square. But here we need, for the same n numbers, we need big omega of n. And in case of theta notation, we are taking the exact time. So we are taking the theta notation. Here we need order of n log n. It takes the exact amount of time. Here we are taking the upper bound and lower bound to calculate the average value. Not the minimum time or not the maximum time. We are taking. So to explain the concept, we have taken the insertion sort. In insertion sort, best case scenario for time required and space required is order of n. For average case scenario, it is order of n square, and the space complexity also, space memory space required to store the values also order of 1. In asymptotic notation form, so the following representations are used. Any doubt what is asymptotic notation? Then what is asymptotic notation means? Order of growth of functions provides a simple characterization of the efficiency. So through the asymptotic notation, we can understand which algorithm is the best and which produces the maximum efficiency. Allows for comparison of relative performance between the alternative algorithms. While choosing a particular algorithm for in your project, we have to choose an algorithm which occupies very less space and very less memory, so that the efficiency will increase. And concerned with the asymptotic efficiency of the algorithm, best asymptotic efficiency usually is best choice for smaller inputs. If you are giving very less number of inputs, say 10 numbers or 15 numbers, any algorithm will produce the output with a very high speed. But when the input size increases, say you are giving 500 numbers, or if you are sorting 1000 numbers, when the number of input increases, the efficiency of best algorithm also will decrease. Several standard methods to simplify the asymptotic analysis algorithms are given. We consider algorithm A is better than algorithm B if the time complexity of A is n, and this time complexity of B is again n. So the A is equivalent to B if both are order big O of time complexity of particular B algorithms also takes n. Why it is acceptable to ignore the behavior of the algorithm for smaller inputs means when the inputs are very less, many of the algorithms will produce the same type of result. And what do we gain by using the asymptotic notation means? So we are getting a mathematical formula. By seeing the formula and by substituting the value, we can calculate and get the efficiency, time and space complexity of the particular algorithm. So we are using always mathematical notations to calculate the efficiency and the time required as well as space required. And while studying the subject topic of asymptotic notation, it allows how the values of the functions compare as their arguments grow without bounds. So when the how the function is performing when the number of arguments are increased in the particular function. It ignores constant and behavior of the function for smaller arguments. If the function is accepting very less number of arguments, the complexity will be very less and it will perform the task very with the high speed. Acceptable because all algorithms are fast for smaller inputs and growth of running time is more important than constant factors. Ignoring usually unimportant details, we obtain a representation that describes the growth of the function. As its argument grows and thus allows us to make comparisons between algorithms in terms of their efficiency. When your program is accepting larger amount of inputs, and in that case, to avoid the time delay and to avoid the hanging problem and other issues, uh, we have to think about the efficiency, space complexity, and time complexity, so that the overall number of arguments, number of inputs, how much scalability of the program should be calculated, so that how fast the program can work when the number of inputs increases. So, any doubt in today's topic, algorithm design, time and space complexity, and asymptotic notations? Any doubt so far?
No, ma'am.
How do we calculate that a particular code is about to take this much time?
George is, I cannot able to hear anything from you.
Am I audible now?
Yes.
How do we calculate the various time complexities uh, for a particular code? Like if it's n log n or like that.
Yes, you need to all those things. We will be studying in design and analysis of algorithms. Anyhow, based on the number of steps in the pseudo code or based on the number of steps what you are using in your program, say if the program is having assignment statements and simple addition subtraction, it takes order of one. And if the statement is having for loop, based on the number of elements we are passing to the for loop, it takes one. Step by step, we need to calculate. Then we will find out the space and time complexity. Say, for example, here, say here we are taking the merge sort. So in the merge sort, the logic is we are taking an initial, the input is in the form. Sorting, you know very well, the numbers input will be in unsorted form. We need to sort. This merge sort is in your remaining topics. Again, we will discuss there. Merge sort means merging the elements, and then by merging first two numbers and merging the third and fourth number, fifth and sixth number, like this. So this is your given input. So in the input, how many numbers are there? Sorting means your the input is in unsorted form. We have to produce the output in sorted form. The array may be having 10 numbers or 100 numbers, whatever it may be. The input will be in unsorted form. The output should be in ascending order or descending order, sorted form. Say here, this is our input. How many numbers are there in the input?
8.
How many
8
numbers?
numbers.
Am I audible to all?
Yes, ma'am.
Okay. How many inputs are there? What is the size of the array?
8.
Okay, there are 8 numbers. All are independent numbers. All the 8 numbers are stored in an array. So this is your given input. So here what we are doing, we are taking the merging, we are subdividing the given list into so many subsections. So we are taking the first two elements as one array, next to two numbers second array, third next to two numbers third array, like that. We are merging these two first two numbers, then sorting. So merge the first two numbers. 5 and 2 is our merged array, and 5 and 2 is in unsorted form because 2 is small number, 5 is big number. 2 should come first and 5 should come next. So we are merging these two, and the 2 is then comparison is made. 5 is greater, 2 is smaller. So the smaller comes first and the bigger number goes second. So this particular array, smallest part is sorted. Then we are taking the next two numbers. This part is already sorted. We are taking next two numbers, 4 and 7. We need to merge, then we have to compare and sort. Now 4 and 7 is merged. When we compare these two numbers, which is biggest, 4 and 7?
Okay.
4 is greater or 7 is greater? Is there any
7.
7.
swapped numbers? Here, the second number is small, first number is big. We are merging and then we are sorting. Here we are merging, then we are trying to sort. It's already in sorted form. No need to swap. So we will leave it. Now this array is merged. This array is sorted. This array also sorted. Next two elements we are taking merging and sorting. Merging is done. Again, already it's in sorted form. Again, here we are merging and sorting. It's already in sorted form. No need to merge. Again, in the first level, we are merging and sorting. Again, in the second iteration, we need to merge these two, then sort. Then merge these two and sort. So when we merge these two, that time itself we are comparing 2 with the 4. 2 is small, 4 is big. So we are keeping as it is, 2 and 4. Then again 5 is compared with 4 and 7. 5 is greater. We are keeping as it is. And 7 is greater than 5. So we are keeping next. So these two subarrays are merged, then sorted. Again, these two subarrays we are merging and sorting. One is compared with 2, one is smaller, and 2 is greater. So we no need to merge, we will keep it as it is. Now we will take 3. 3 is compared with 2, 3 is greater, 2 is small. So we will place 3 after 2. Then we will compare 3 with 6. 3 is small, 6 is greater. So we will keep 3 first, then 6 second. Now this array is sorted, this array also sorted. Now we need to merge these two, then sort. While merging these two and sorting, take the first number, compare it with all, because it is already sorted. Here we cannot swap. Again, this is also already sorted. Here we cannot swap. Now we'll merge together, then we will sort. We'll take the first number, compare it with all other numbers. If any number is smaller than 2, that number will be swapped. So when we compare 2 with 1, that time 1 is small compared to 2. So keep the 1 in the first place, 2 in the second place. Again 2 is compared with 2. Both are same. Keep 2 and 2. Then compare 2 with 3. 2 is small. Keep 2 first, then 3 second. Then 2 is compared with 6. 2 is small, keep the 2 in its place, keep the 6 in the next place. Then take 4, compare it with 1, 2, 3. These all three numbers are smaller than 4. When we compare with 6, at that time 6 is greater. So what we will do, we will keep the 4 after 3. Then you take the 3, compare it with the 2, 3, 4, 3 and 6. So in this case, 1, 2, 3 is smaller than 5. Only 6 is greater than 5. So we will take 1, 2, 2, 3, 4, then 5 and 6. Then you take the 7, compare it with the 1, compare it with the 2, 7 compared with 3, 7 compared with 6. All are smaller numbers. They will be in the respective places. 7 is the biggest number that is placed in the last position. So like that, according to merge sort, the logic is, this is your given input array, merge first two numbers, then sort, merge remaining two numbers and sort, remaining two numbers and sort, remaining two numbers and sort. You are in the first level. Again, merge next two sorted arrays, merge and sort, merge and sort. Again, merge these two and sort. So this is the logic behind merge sort. Here, if you write the corresponding code for the particular merge sort, according to the merge sort algorithm, we need the array, we need the P, Q and R, where P, Q, R all the small subarrays. We will take the first array N1, it is equivalent to Q minus P plus 1. The next smaller subarray N2 equal to R minus Q. So here, if you write down all those steps for this particular merge sort algorithm, anyhow this concept we will explain the remaining topic once again. Here, any assignment step, here the corresponding steps are, here it is an N1 equal to some assignment process. It is an arithmetic assignment statement. For this particular arithmetic assignment statement, all the assignment statements we need order of 1 time. So these two are assignment time, assignment process, arithmetic assignment statement, both required order of 1, order of 1. Here, for loop, the for loop is repeated for I equal to 1 to n times. So we need order of n time. Again, this particular j loop, we are repeating it for 1 to n2 time. So for to complete this process, so this is executed for n2 times. Every time when we iterate, we need order of 1, order of 1. So this particular for loop needs order of n. This order I loop order of n, j loop order of n. And again, it is an assignment process, arithmetic assignment statement, order of 1. J equal to 1, I equal to 1. This is also we need order of 1, order of 1. So when we are doing design and analysis of algorithm, or when we are calculating them microprocessor instructions, we will have one byte instruction, 2 byte instruction, 3 byte instruction, like that. So all the 1 byte instructions need order of 1 time. So based on that, we will calculate how many steps are there in your program. And if it is an assignment process, for every assignment process, we need order of 1, order of 1. And here order of n, order of n, order of 1, order of 1. So we'll add together. That's what the merge sort. So time complexity is order of 1 into order of n into order of 1 into order of n. All together, we will get order of n square. In that way, we will calculate the time complexity. Say here we have merge and sort, merge and sort, merge and sort. Time complexity of n numbers divided by 4, n numbers divided by 4. When we merge and sort, we will get order of n by 2. Again, we merge these two, we will get order of n. So the time complexity for this particular algorithm is order of n into n, order of n square. So like that, for each and every step, we need to calculate. Say here the numbers are independent numbers. Merge and sort, we are getting n iterations, order of n. Again here order of n. Again here order of n, order of n. So the time complexity of n for this particular merge sort is Cn of log n plus 1, n log n plus Cn. So the total time complexity in theta notation, average notation is n log n. So for how each and every instruction, how we are calculating time complexity is mentioned here. Like that, we need to calculate. So we discussed what is asymptotic notation. In the first class itself, we discussed what is data structure and introduction to data structure and classification of data structure. So if you take the data structures, we are discussing the following topics: the fundamental concepts of programming language and the character set and basic concepts you should know. Then the various data structures available like arrays, linked list, queues and stacks we'll be studying, and various algorithmic concepts like greedy algorithms, divide and control algorithms we'll study. Sorting and searching algorithms will be part of this, and recursive techniques. The function calls itself is also part of that. The advanced topics like backtracking algorithms, string algorithms, bit manipulation algorithms also will be studying, and the trees and graph structures we will be studying, and other advanced data structures concepts like hashing techniques, heap structures. So they are all part of the data structures and algorithms concept. So as we discussed, DSA means data structures and algorithms. It is a fundamental concept in computer science that involves the study and application of various methods for organizing and processing data. This definition and these concepts we discussed in the first class, I think 14th class, 14th June class. As per the definition, data structures refers to the way the data is organized and stored, while algorithms are step-by-step procedures or formulas for solving the problems. And various data structures available in many of the programming languages are arrays and linked list, stacks, queues, trees, and hash tables. In the same way, we have algorithmic steps based on searching techniques, sorting techniques, recursive techniques, dynamic programming, greedy algorithms, and divide and conquer algorithms. What is the definition of data structure and algorithm means? Data structures, those are specific formats for organizing and storing data in a computer. In computer, when we enter some array of n numbers, how it is stored, how much memory space allotted for each and every number, and how it is stored along with the index values, and how we are accessing and doing the process. The way data is stored in the memory is called data structure. And examples include arrays, linked list, trees, graphs, and hash tables. And various algorithms or step-by-step procedures or formulas for solving the problem. In computer science, algorithms are used to perform calculations, data processing, and automated reasoning steps. It is a fundamental concept in computer science that involves study and application of various methods for organizing and processing the data. So the same definition repeated. If you take data structures and algorithms are fundamental concepts in computer science that play a role in the complex problem solving techniques. They are building blocks for any computer application or system, allowing for efficient data organization, storage, and retrieval. To store the data and process the data, update the data, and to retrieve and display the data, we need data structures. And data structures refer to the way data is organized and stored in the computer's memory. It provides a systematic way to manage and manipulate data, enabling efficient operations such as searching, sorting, inserting. Common data structures include array, linked list, stack, and queues. Algorithms are step-by-step procedures. They define the logic and instructions required to perform a particular task efficiently. Algorithms can be simple or complex depending on the problem-solving method in hand. So any doubt what is a data structure and what is algorithm? Introduction part. To take the classification of data structure, this slide also we discussed in the first class itself. Data structures means may be a built-in data structure or it may be user-defined data structure. What is built-in data structure? I think in your memory also, mobile also, you can find built-in memory. What is the name of a built-in memory and secondary memory? Sanket,
Yes, ma'am.
what do you mean by built-in memory or basic memory?
Ma'am, built-in memory are the memory are the data structures given by are pre-built in the IDs. I mean the coding parts.
In your mobile, you can see RAM and ROM and external memory also. RAM will be 8 GB. Your secondary memory may be mobile configuration. What we are getting? We are getting 8 GB RAM minimum. That RAM is random access memory, which is used for storing the operating system programs. Your Android operating system and built-in functions, calculator, clock, some other built-in apps. The same way in laptop also we have RAM and ROM. RAM may be 16 GB or 8 GB, and your SSD may be 512 MB or 1 TB. So where RAM is the inbuilt memory, SSD also primary memory, and the SSD can be extended by through the slots. So where RAM is the inbuilt memory or built-in memory. The same way, every programming language is having its own character set and its own built-in uh, numbers as well as characters, which is part of the programming based on the, say, every language. It may be Hindi, English, or anything. English also having its own characters, 26 characters, and it supports the numbers 0 to 9 and the combination of numbers and other symbols, Roman letters also. The same way, if you take Hindi also, it's having its own character set. As part of the character set, some built-in number system also there. In Roman number system only, they are using different notation. Most of the other programming languages, we are using regional languages as well as in programming languages, we have numbers 0 to 9, then the combination. We can perform addition, subtraction, all those things, and we have characters. They are used to create the words and sentences and paragraph in that particular programming language or in the mother tongue or any regional language. The same way, the built-in data types are part of the compiler, or without that built-in data types, characters, float, integer, and double, we cannot do anything with the program, because if any language should have its own alphabet and character set. Based on the alphabets only, we are forming the words and we are forming the sentences and paragraphs. We are communicating with each other. Just if you are communicating, we are using words, or if you are doing some calculation, I am giving 10 rupees, you give me, you have another 5 rupees, total is 15 rupees. So some mathematical calculation is also part of the language and communication. So the compiler inbuilt data types are called primitive data types. Every programming language is having the primitive or inbuilt data types like integers, characters, float, and double. And by making use of the built-in data types, we are creating the user-defined data types, an array of integer, an array of float, and list file structures. We are storing all the data. And if it is list, it may be list means linear structure. It may be stack or queue. In stack, we are performing push and pop. In queues, we are putting front and rear. And it is performing last in, first out. It is performing first in, first out. And if it is non-linear, we are representing the data in the discrete form in terms of tree structure, parent-child, grandchild relationship, or in graph structure, root node, or predecessor and successor, like that. So they are all the different data structures used in most of the programming languages. Okay. So you go through the topics what we discussed today. So if you have asked me in the next class, the session